Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is going to be another in my series of practice sessions for the RHCSA exam. The topic I'll be covering today is under operating running systems, and it's identify CPU/memory intensive processes and kill processes. So I want to remind you that this isn't intended to be authoritative information as much as it's me going through the concepts just to see if I feel like I know what I'm talking about, so I'm hopefully prepared for the exam. The benefit from it for you is perhaps you're working on the exam itself, or rather working on preparing for the exam, and I might present something in a way you haven't thought about before, and so it might help with your own learning. As with everything, if you enjoy the content of the video, make sure you click like. Likes really help the channel as far as like YouTube's algorithm and such. And also, if you further enjoy the content of this video and other videos I've made, feel free to subscribe to the channel and ring the bell when you do, so you can be aware when new videos come available. So I'm here in my CentOS VM. I have a couple of terminal windows open because I want to. There are a few things that'll be easier to visualize it with two windows. First of all, the first part of this is identify CPU and memory intensive processes. So I encourage you, if you like tools other than what I'm going to show, feel free to make a comment and list those tools. I know, well, the tool I'm going to show you first, let me do that, is just the top command. And I know there are others. There's Glances. I haven't used Glances before, but I've heard of it. As far as being able to identify memory and CPU intensive processes, which is what this objective is saying, the only tool that I know of that is pretty much baked into almost every system is the top tool. If you know of others that are baked in, feel free to leave a comment about that, because I'd love to learn of more, because I'm all about trying to have a couple different ways of solving a problem. But the top command is one that I think a lot of folks use. I know that I myself have used it, and it gives you a lot of good information. It will show you your load averages. As far as this is getting into queuing of processes and such, if you have high load averages, that doesn't necessarily mean that your system is starved for resources as much as it means that there are a lot of processes that are waiting their turn. So it's possible to have like low CPU usage but high load averages, where the process that's making things have to queue up isn't really chewing a bunch of CPU, but the CPU is waiting on that process to finish whatever it is it's doing before others get in there. I know there are some. I'm trying to think. I know when I was working on this with Linux Academy, there was an explanation that talked about like using more than 100% of your CPU. Like if you have a single core system and your load average is 4, that means you're using 400% of your CPU. I'm not quite sure how that's possible, because 100% is 100%, right? Now you could have a lot of stuff in queue, which would raise the load average, but I would caution you to think of load average as like this one-to-one relationship with CPU usage. And if you think about it, ideally you would like that CPU to be used almost all the time versus sitting there and being idle. Now I'm not saying you should peg your CPU at all times, but when you're designing a system and such, let's say that you spent $10,000 on a server, and that server's running your hypervisor and running your VMs, and you find that under full load of your of whatever your production workload is, that server is just barely using any CPU. Well, I mean, yeah, you have a lot of room to grow, but at the same time, could you have bought a server that was less expensive and better tailored to your needs? Anyway, that's outside the scope of what I'm wanting to do here, but it kind of gets into the business practice in IT. So back on topic, or at least trying to do that. Load average with this, you have three numbers: the 1 minute, 5 minute, 15 minute, if I remember off the top of my head correctly, and that's just showing you your averages over that amount of time. And if you find those getting significantly high and above one, if you have a single core processor, two, if you have two core processors, on and on and on, then that might indicate that there's something going on that's causing processes to queue up rather than being immediately executed. Top also shows you percent CPU usage for processes. It shows you memory percentage. It shows you processor time as well. I'm not super knowledgeable about exactly how processor time is calculated. I'm not sure if it's like linear time that you and I know of, 10 minutes on and on and on, but that information is there for you. It also shows you priority and niceness level. Priority is related to nice. Niceness level is the preference that a process is, or I hesitate to say is going to have, because it's almost more of a suggestion, with -20 being processes that have the highest priority as far as you get the most attention, and nice level of 19 being processes that are not as important, and of course 0 being the halfway point. Top also shows you the process ID, which is going to be useful when we're working with the kill command. Also shows you the user for that process, and will show you the command that's being done. Also gives you information about your memory usage and such. Also gives you some uptime information. So a lot of stuff you have at a glance with Top, and you see it refreshing every couple of seconds. I believe by default Top will refresh every 2 seconds, but that can be altered as well. One other thing you can do with Top, let me quit out of this and go into the man page for Top, because I remember having to do this once before. See if I can find it in the man page here. Where's this at? There's a certain parameter you can give Top that makes it useful for giving the out. It's B, batch mode. So let me show you what I mean by this. If I were to try to do Top, and I'm going to redirect that output to top test.txt, and stop that. Cat top test.txt. You have, or let me do less top. Gives you a binary file, which is kind of odd. So let's do seed anyway, see what happens. And nothing occurred. Let me tell that yes. Gives you a bunch of stuff that's not useful. But if you do Top with -B, and believe that will give us a little bit better data. Oh, not ls. ls command. You're probably watching the video thinking, you actually know anything about Linux? You just use ls for that. There we go, and that gives us a bit more information. And you can do other parameters that will like show some little like snapshots of Top, but that's just one that I wanted to point out there, is the -B, if you're ever wanting to take that output of Top and send it to a file as such. So you would use Top to identify what might be running slow and such, or rather, if your system is running slow, you can use Top to identify processes that are potentially causing that problem. So the question becomes, all right, how do we deal with these processes? Well, let's do this. I'm going to do a little script, and I'm going to say while true, do echo making text. We're going to send that there, done. All right, and so this loop's going to go forever, while true. Well, true is always happening. So if I were to go in my other command here, do Top, you will see my process here. It's chewing up a good bit of CPU, a tiny bit of memory. and the load averages are going to eventually start to raise because stuff might get queued up. Now this is a multi-core system, so a load average of 1.84 is not bad for this system by any means. But if I wanted to stop this process, if within top, you can press the K key, and what that's going to do is send a kill signal to whatever process that you want. Now by default, it takes the whatever process is at the top of the list, which happens to be the process we want, this 3765. If I were to press enter, it's going to ask what signal to send to it. Kill signals, unlike what the term means in English, kill does not always mean eliminate a process. Rather, it's the operating system is sending a signal to a process to make it do a certain thing. We often use kill to stop a process, but that's not 100%, its only use. And so by default, we're going to send the sigterm signal, or 15, and we should see that process go away, hopefully. Now there's a difference in kill signals, and this will be something I get into in just a moment. Let's try kill again. And instead of 15, we're going to do 9. And that killed the process. Now the difference between kill signal 9 and 15, if I were to do kill-L, that'll show you all your signals. 15 is finish up what you're doing and terminate cleanly. Hence sigterm there. Such as if you have a program that you want to kill, but needs to finish up a couple of things, sigterm allows that to happen. Well, with my little program, it's an infinite loop. There's no cleanup that it's going to do. So situations like that, let's say you have your process that just is not behaving, it will not kill cleanly, then we send it signal number 9, or sigkill, which is do not pass go, do not collect $200. Is it 200? I guess I don't know if Monopoly's changed much, but it is just flat out stop the process, stop cold. So, let's say that you have something that would normally do some type of action of writing to a disk as its normal termination procedure. If you send it sigkill, doesn't get to do that. It is literally stop right now in the process. And as you can see, that terminal window itself closed because it was bash was the program that was running. So let me open the new window, and I should have my file there. Yep, top test txt. And if I were to tail, oh nope, that's what. Oh, I'm sorry, it's while text, man. All right, so if I were to tail while text, there's our little making text. If I were to do ls-lh, we see that while text is 46 megabytes worth of text, which is a ton. Now, you do not have to be in top to be able to send kill signals. You can do that outside as well. So let's take, I'm going to echo. Let's do this. I'm going to make the little command that I just did to do that loop. I'm going to turn that into a little script. So we're going to echo this text. While test.sh. I'm going to edit that because I do want to did that after the line. I'm going to add what you should add for bash script. And I'm going to start this, give it execute privileges, and it has execute privileges. I'm going to start this script but send it to the background. So let me remove some stuff. All right. So we're going to start this script and use the AND operator to send it to the background. So process ID 4779, and it is job 1. You can do the jobs command to see what jobs are running right now. So let's say that I don't want to use top to deal with this. I wanted to use the kill command. All right. So with kill, you can either give it the number of the signal you want to send or the name. I tend to do names just because for some of these names it's been easier for me to remember rather than the number itself. The command that I want to send to it, rather than terminate it or kill it, I want to send the stop command. So I can either do -19 or sig stop. And I can either give it the process ID or the job number. If you do the job number, it has to be preceded by a % sign. So I'm going to do %1 for that job. And what that has done has stopped the script. The process is not dead. If I were to do PS AUX grep 4779, there is still a process there, but it's currently not running right now. It's in a stopped state. And case in point, if I were to do word count -L on while.text, should have a, I'm doing it into hello. No. Gotta love live demo stuff. What am I doing here? Yeah. Oh, so it's doing it to hello. The reason why I'm a little surprised that was something I was doing during some of my tests prior to starting the video. Anyway, so if I were to do this to hello, we see there are 2,567,087 lines. If I were to do that again, it stays the same. But if I were to do the kill signal sig cont or sig continue, so this time I'll do the number, so that's -18, and the job %1. It's going to continue. And we see that there's more lines. Now I can also give it the process ID. Let me do jobs. Shows we have one job running. I remember the process ID from before, 4779. And let's try kill -19 sig stop 4779 for the process ID. Alright, so that stopped that job as well. Even though I didn't give it a job number, I gave it the process ID. And then if I wanted to do kill, actually we'll go ahead and do kill 9 to just end it. Alright, so now it's gone. We have our little hello. Let's do the word count again. -L tells you how many lines rather than individual words. So it's kind of an example of how to manipulate some processes with the kill command. A couple other kill commands that, or I keep saying kill commands, I should call them kill signals, that I want to show you. One is sighup, and sighup stands for signal hang up. So if I were to, let's do, actually we're going to do another little thing here. So Pgrep, kind of stream of consciousness here. Pgrep is a command that combines the PS command with grep. And one nice thing about this is you can search for names of commands. You can also search for owners of processes and such. Now you can do this with PS as well. You can do PS AUX and pipe that to grep and basically do the same kind of search. This is a little bit of a shorthand for it. So I want to find processes owned by Eddie, which is my user account. If I were to do that, we have a lot of process IDs. And I believe the -N flag is going to give me the name of the process. Nope. Is it -L? It's -L. That's it. So from here, I may be able to do just bash. Yep. All right. So there are two bash processes open, which makes sense. We have each of our terminals. I'm going to go over to the second terminal, and I'm going to send a kill signal. I'm going to do -1 for sig hang up to 3507. And that was that one. So hang up is literally as it says. Like, let's say you have a console session where there's an SSH session here, you can send that hang up to that particular process, and that will effectively end the session. It's not the exact same as kill. It's not the exact, kill. Sig kill. It's not the exact same as that, nor the exact same as sigterm, but it's literally kind of like hanging up a phone as well. I'm fairly sure, let me get my kill list again. And this, by the way, I fully intend to use on the RHCSA exam. Is, you can probably hear the motorcycle outside my apartment, is use this as a reference. And I believe sigint is what I'm thinking of. You have something going and you use Control-C to end that. I'm fairly sure that Control-C is the same as sending the sigint kill signal to whatever the process is that is affecting. If I'm wrong about that, feel free to put it into the comments, but I'm fairly sure that that's what we have. So for this objective, identify CPU/memory intensive processes and kill processes. We went over looking at top. Oh, I did want to mention something with PS. Let me go to the man page for this. Notice it has several kind of options, Unix, BSD, and GNU options. I find myself using the Unix options more often. A lot of examples I see use that, and those are the options without the dash. And I do want to encourage you, as you're studying, is probably pick one, because the one that you see a lot, PSAUX and PS-AUX will give you similar output, but it is not the exact same. So I encourage you to check out the man page on that. And just know, at least in my experience, a lot of the examples I've seen of using PS uses the Unix option, which is the options that don't have the dash. We also looked at Pgrep as far as a way to search for processes. There is a pkill as well. Pkill can be useful if you're running Apache and you want to kill all the Apache processes. Well, if you do that, Apache will have several HTTPD processes that are running, and using the pkill command HTTPD will basically run pgrep and find all the processes named HTTPD and kill them, I believe, using signal 15 for that. Pkill is not one that I use that often, just because I don't want to accidentally kill a process, but it is there for you. So I hope you found this useful. If you did, make sure you click like and on the video. Also, feel free to subscribe to the channel, ring the bell when you do, and don't hesitate to put in some comments in particular with this. Like I said, if you know of something other than top that's like pretty much always baked into a system to be able to give some real-time process and memory stats. And also, if you have other utilities that you like to use for these, I'd love to hear about them myself, because I might add that to my own toolbox. So as always, thank you for taking the time to watch, and I'll see you the next time.